We are completing Katerina's section exactly on time, which is wonderful. And I would like to introduce our next speaker. She would be Alison Henry, that's right. She's the engineering librarian for the Cameron Library from the University of Alberta. Alison Henry is also a member of the library's research impact team. And she comes to us. She has a chemical engineering degree from Queen's University and an MLIS from the University of Alberta. We welcome Alison for her talk, Blasting the Big Deal, using citation analysis to support decision-making around journal cancellation. Alison, please, the floor is yours.
Thank you very much, Lisa. I'm happy to be here today. I do have to start off actually with an apology. I feel like this presentation title is like the conference version of clickbait, in that this is a work in progress. No decisions have been made at this point in time about breaking up big journal packages. Though I have to admit that personally, that is very much the way I would like to see some of this go. But I hope you will be, I hope you'll still be interested in some of the ways that we are looking at this information and trying to inform our decision making in this regard. Now I'm also looking for the control. Oh, here we go. Okay, so a bit of background. This analysis comes at a time when we're looking ahead. We have multi-year deals for a lot of our big journal agreements and consortial agreements for a lot of these packages as well. So none of the decisions that we take in examining these packages happen very quickly, but this does give us a good opportunity to try new things in how we analyze our journal use. And so the goal of this project was to take one of these packages, in this case our Springer Nature collection, and see if we could combine both our item request data, our sort of view and download data that we get from the vendors, along with information about University of Alberta publications in those journals and citations by University of Alberta authors to papers published in these journals. And we wanted to look at these three different measures and see if we could combine them into one form of use, or one version of use. Yes, okay, so we're going to group the journals into clusters based on those three measures of use and facilitate comparison between these journals, there are over 3,000 journals in this package across many, many different subject areas. So hoping to give us a new way to look at them. In order to gather the data needed to inform these types of use, we got our view and download information comes from the vendors' usage stats. For the publication data, we searched Web of Science for University of Alberta authors in our particular date range of interest and collected those publications. We also ran some searches in Scopus to gather information, specifically publications in the journals not indexed by Web of Science, so the journals from our Springer list that are not indexed there. For the cited reference, for the citation piece, we used that Web of Science search of all University of Alberta author publications in our time frame and exported the cited references of those papers. And then our journal category assignments came mainly from Web of Science and, of course, pulling a few from Scopus as well. Now, all of this data required a certain amount of cleaning and preparation to get it into a format that we could use for this analysis. For example, the sources in the cited references are all in abbreviated format. So we had some information service staff in the library look up the abbreviations in Web of Science's journal abbreviation table. We were not able to find abbreviations for all of these journals because, of course, not all of the journals are even indexed there. But we found abbreviations for 1,819 of the journals in question. We converted source titles from all of our various lists into lowercase and trimmed white space to facilitate text matching. And also, in general, this data is very positively skewed. So we ended up doing log transformations on the numbers in order to be able to run the clustering algorithms. So as a summary of what all of this got us, we identified 42,215 publications by University of Alberta authors in Web of Science over our date range in question. And of those, 3,262 were published in Springer publications. We added an additional 102 from Scopus to bring the total to 3,364. And these represented 817 unique journal titles. From those 42,000 papers, we retrieved 1,700,867 references, of which 107,727 were to Springer journals. And I'll also mention at this point in time that initially we were doing this on the entire Springer Nature package, but it turns out, probably unsurprisingly, that Nature is a total outlier and really threw off all attempts at clustering with the inclusion of Nature itself and several other Nature titles. So our collection strategy unit actually asked us to ignore all of the journals on the nature.com platform and focus specifically on Springer for this task. So that's what these numbers represent. Once these lists were merged, it was obvious we did not have evidence of all types of use for all titles. In some cases, for these types of statistical analyses, missing values will be replaced with perhaps a mean, but in our case, we considered that if we found no evidence of publication, then publication was probably 0 for that journal. So all of those NAs are replaced with zeros. We had 817 titles in which UAlberta author published, 1,623 for titles that were cited by University of Alberta authors, and 2,577 which had some viewer download activity. Now, there are several limitations to the analysis as presented here today. For one thing, we have a single source of citations. Since this was kind of a proof of concept project, we did not think it was worth the time to retrieve the citations from Scopus as well and attempt to do the deduplication that would have been involved in getting an accurate list in that respect. We also are using 5 years worth of publication and citation data, but only 1 year's worth of item request data. Publications and citations were summed over that 5-year period to give us 1 count for each of those measures of use. Also, because our data comes from some places that do have ISSNs included and some places that do not, all of the matching of titles to merge everything is done on text matching, which has led to a few obvious errors or duplications that we've tried to correct, but probably didn't do a perfect job of. We're also missing category assignments still for some of these journals that did not auto-fill very well. So that piece is especially a work in progress, but I can still show you what we're hoping to do with it. Okay, so a brief explanation here about Kmeans clustering. I'm not sure what kind of statistical background most FRIC attendees have. So I'll just do a kind of a very simplified version of what this technique is meant to accomplish. This first graph in the top left corner of the slide, the unfilled dots represent our data points, and what this algorithm, you tell the algorithm how many clusters you think you should have. So in this case, the yellow triangle and green triangle represent the two starting point centroids for our two clusters that we're trying to form. And so the algorithm will look at those centroids, look at each data point and assign it to the group to which it is closest. So these ones all turn yellow, and the data points sort of in the top right of the graph all turn green. Now, once that is done, then we recompute the center of each cluster, and that is illustrated here by the graph in the lower left-hand corner of the slide showing the triangles moving position. And then the points are reassigned. We again look and see, okay, which centroid is closer for each data point. And you can see that some of them move from one cluster to another. And this process is repeated over and over again until either convergence happens or most of the time you're setting a fixed number of iterations you intend to complete. And once it's done them all, then it stops. And the goal, the benefit of this is that we can, of course, do it over, this is a two-dimensional plot, but we can do it over more dimensions of data using more variables than just the two represented here. Now, of course, because we have to tell it how many clusters we are, we need a method to figure out what is the correct number of clusters for our collection of journals here. So in order to do that, we ran the clustering algorithm many times over different values of K, and then plotted this graph to see which one gives us the tightest clusters. And what we're looking for here in the elbow graph is really the bend in that elbow, the point where adding new clusters doesn't give us as much benefit in terms of reducing that sum of squares distance. So in looking at this plot, we chose 5 as the appropriate number of clusters for the data that we have. Because you can see at that point, the drops are not as significant. When we did that, we ended up with clusters that are not that evenly distributed. You can see here the number of titles that ended up in each cluster. And then I have a couple of other ways to visualize what's happening with this clustering. So this silhouette plot gives you an idea of how many data points are assigned in each cluster, and the little bits of color that go down below 0 there are an indication of points that are probably misassigned, that are probably in the wrong cluster. But overall, we have an acceptable level of clustering with this plot. If you try to visualize them another way, we can see that cluster 1 is distinct, whereas the other ones seem to have a lot more overlap. So we looked at, as our clusters are assigned, this is the plot that I think is most helpful, at least in this two-dimensional space, to visualize what's happening. And this is how we began to interpret what these clusters represent. So cluster number 1, the purple dots, we're terming these our high use journals. These are journals that show high levels of use, both in views and in citations, and some UAlberta authors publishing in these journals. The yellow cluster 5, we're calling these our moderate use journals that represent quite a bit of citation and view for those journals. And the green ones we think of as our low use journals. And they're not really not seeing many views, not seeing much citation use either. And then we have these other groupings. Cluster number 2, which we're thinking kind of as more educational use. So these are journals that show high numbers of views. Lots of people are looking at these journals, are viewing or downloading the articles, but those journals are not really being cited by our authors. So we assume that this is sort of non-publisher use, so probably student or undergraduate use of journals. And then finally, this sort of mystery third cluster number 3, which I'm referring to as an open access cluster, because these are journals that do show lots of citations. So obviously our researchers are accessing the papers in these journals somehow, but it's not through our library subscriptions, because we show very few, almost no views of these journals. Now, at this point, I am going to try to share my screen instead to just give you a couple of other ways to visualize this. I did make a 3D plot to show these clusters, and I will share the link if I can, perhaps in the chat, and maybe Lisa can share it out to everybody. If anybody wants to play around with that. And then also we needed to look at the subject category piece. And this is the tricky part to kind of understand, because we are looking at 225 different subject categories. It's a little hard to picture what's really going on in these different subject areas. What I've done here is calculate the mean number of citations and the mean number of views for the journals in a given subject area. So each dot represents a subject area. In this case, this example is ecology. And the size of the dot lets you know how many journals, or relative number of journals in that subject area in this cluster. So here we're zooming in on that high use cluster, and we can see we have large number of pharmacology journals represented, endocrinology and metabolism, geosciences, a lot of health sciences categories showing up in this high use area, and a lot of natural sciences and engineering, I would say, are showing up in this category, which especially that health sciences piece is not that surprising given what we know of publication patterns in the discipline. In the moderate use category, it's much more spread out, and you can see that there aren't really there isn't really the same sort of variation. The groupings are much more the same size, or particular subject areas that dominate in the same way. And similar with the low use plot, we again have subject areas sort of all over the place, and no big groups. What I do find interesting is actually, since we're getting close to time here, is I'm going to skip over the education to the open access plot. And the subject areas showing up in this cluster of journals are almost all health related in some fashion. We've got medicine, we have public health, we have some specific branches like urology, geriatrics and gerontology, genetics. So I don't know if there is a lot more open access publishing in health sciences than in these other subject areas, but it is very interesting to me that this is where we are seeing a high number of citations and access coming not through the library provided access to these subject areas. So I'll just close by mentioning that we do have some remaining questions with this work to go through the lists in each cluster and see, for example, with these OA, with these ones that I'm calling the OA journals, are they actually open access journals? Can we explain what's going on here with obvious research use but no measured access to them? And also, I would love to hear feedback, I guess, from people in this group on if there are other ways we can use the category information as well, because it seems to be the kind of the hardest piece to examine with this. And I will end it there and see if anybody has any questions.
Oh, thank you, Alison. I thought that was great. We do have a few questions. If you'll just give me a second, I'll be able to scroll to them. Okay, the first question that came in, it was around the beginning of your talk, and I apologize I didn't catch exactly what slide it was. But the question is, when you mention use, are you largely looking at views, downloads, or citations?
Okay. Well, kind of the point of this is to, we're not separating the views and the downloads. So the statistic that our collections team asked us to use for this is the total item requests, which as far as I know, for both of those things. And then we are looking at citations and publication, two other types of use that we want to include, that we want to recognize when we're trying to determine whether a journal is used. So precise enough as I speak about this, because I think of all of those things as some measure of use of these journals, and the goal is to try to combine them.
Another question. Did you do the clustering yourself? How easy is it to apply and use this method?
So I did the clustering using R, which is a statistical, a coding language often used for statistical analysis. There are packages in R that can handle, there are Python packages, MATLAB packages. I'm sure any of the big statistical analysis software options will all have algorithms provided to do this type of clustering. So if you are, I guess it depends on your level of comfort with those types of tools, but it's quite straightforward. As long as it's much trickier getting your data in an appropriate format to be analyzed than to actually run the algorithm. Running the algorithm is very quick and easy.
Going back to the first question about views or downloads, what insights did you gather or garner from each?
Well, I did find it interesting that seeing some of those different patterns, that we did have this whole category of journals that had very high levels of use that do not show any publication or citation necessarily in those journals. And so it really speaks to all of the different things that are happening on our campus, right? We have students who are there to learn, but who are not participating in this scholarly enterprise in terms of the publishing and the citing other works, right? And we have researchers who are very much invested in that. So we did have a little bit of a discussion with the collections team around whether or not we should be weighting any of these things, or in order to kind of prioritize one type of use over another. Personally, I see probably the publication type of use as maybe the least meaningful in our decision making, because I don't feel like it involves the same kind of judgment that's coming when an author chooses to cite work in a particular journal. But at this point, we've left them all the same. We didn't weight anything differently.
Another question on the OA plot. I wonder if this is to some degree a PubMed Central / PMC Europe effect, where the full text is available from outside repositories in addition to the publisher pages.
That seems like a very reasonable explanation to me, especially given how, we do have a few other things, math showing up in here. Maybe math, just for everyone's information, was the category with the highest number of journals in it of all of the journals we looked at. But yeah, I think that's a very reasonable explanation for why we would see this pattern.
And then our last question is, you commented that cluster 3 was your OA cluster because they had lots of citations but low views. Assuming that they were being viewed outside of the gated library platforms, is it not an assumption that high citation implies high views. And I think you also mentioned at the end of this, but there are journals in this cluster that is actually open access.
Well, I was thinking that they must be open access to account for this. If people are, yes, I agree that the fact that they're being cited means somebody has viewed them, but they have not viewed them in a way that we are able to track. So traditionally, if we were looking, sometimes in our collections decision making, we'll look at things like cost per use, and that use is a statistic like this one. It's like the total item requests, or it's based on counter stats or that sort of thing, right? And this is evidence that there's lots of use happening that the library isn't facilitating, I guess. Yeah.
Right, right. Okay, well, that concludes the questions. Very good questions to a very interesting body of work that you've done at the University of Alberta. I actually have a few questions myself, Alison, but I'll ask you at a different time, perhaps through.
Absolutely.
Wonderful.
Great.
Anyways, everyone, this concludes our early afternoon session. We will have a bio break right now, and we look forward to seeing you back here at 3 p.m.